So good morning. My name's Dave Wheeler. I work, as he mentioned, at the Institute for Defense Analyses. I'm very interested in defending software against attack. I also support the Linux Foundation, which is primarily what I'm going to be talking about today. So I'm going to be talking about the Linux Foundation's CII, or Core Infrastructure Initiative, Best Practices Badge. I'm the technical lead of the project. And my hope is that I will inspire many of you to either work on your projects getting a badge or encourage the projects that you're involved with getting a badge. So let me explain a little bit about that. First, I'm going to very, very briefly give some background that may help, especially those who aren't familiar with the Linux Foundation. So first of all, I hope that all of you will understand, I have to deal with people from very, very different backgrounds who have very different preconceptions about open source software, which are often mistaken. It is absolutely not the case that all open source software is insecure. I meet those kinds of people, particularly if they're from companies that are selling competing products. However, it's also not true that all open source software is secure. Just like all of the software, some open source software is relatively secure and some is not. This was particularly brought out to bear in 2014 with the Heartbleed vulnerability in OpenSSL. And this really demonstrated to a lot of people what really was already the case, that there was some widely used open source software that nevertheless really needed some kind of investment for security. And so the Linux Foundation created an organization inside it called the Core Infrastructure Initiative. And the mission it's to fund and support critical elements of the Global Infrastructure Initiative. So here's a little more about the CII, just briefly. It's a multi-million-dollar project supported by many, many companies. You would recognize a lot of these names, I'm sure. And it fundamentally can be talked about in terms of three actions. It collaboratively identifies and funds open source software projects in need of assistance. It allows developers to continue their work. It is not the goal of the CII to take over projects. It is the goal to help projects do a better job of what they're already doing. And finally, the CII is transitioning from point fixes to holistic solutions. This does not mean the CII is not interested in helping specific projects. They still are. However, there are so many projects out there, open source software projects, that someone depends on, that it is difficult to fund every single project that someone thinks is important. So instead, the CII funds a few that are very important, that are widely used, and also funds some activities that can help sort of raise all boats, as it were. Here are some investments in some of the key open source software projects. The graph on the left, for example, shows OpenSSL. The Linux Foundation CII funded OpenSSL, including some key developers, focusing on things like improving security. The graph here shows the number of issues. Up until 2014, there were more and more issues being requested, more tickets, but no one actually responding to them. And suddenly, as of 2014, a huge number of tickets were resolved one way or the other. And they're working with other projects, including, for example, auditing the code and so on. The CII also funds projects that have multi-project impacts. For example, it funds an organization called the Fuzzing Project, which uses tools called fuzzers that send random data into programs, but a very large amount of it, looking to trigger vulnerabilities of different kinds. This has found a number of vulnerabilities that have since been fixed by the various open source software projects. I led development of something called the CII Census. This was some quantitative work to analyze many different open source projects to try to identify which projects are particularly in trouble, higher risk, and nevertheless widely used and perhaps most in need of funding. And finally, the focus today is the Best Practices Badge. Okay. All right, so open source software, I think will be unsurprised to know, tends to be more secure if it follows generally good security practices, undergoes peer reviews. But how can we encourage those good practices? In fact, how do we know what those are? And never mind, how can we know if they're being followed? So we developed a simple approach. First, we tried to identify a set of best practices for open source software projects. And here I'm focusing on production side. In other words, what are best practices for open source projects that are developing software, not the reception side, what are the best practices for examining software you might bring in. And this was based very much on existing materials, existing practices already used by various projects. Once we identified criteria, we created a simple web application where open source software projects can self-certify. And if an open source software project meets those criteria, they get a badge. And the advantage of self-certification is that it scales. Now, there are problems with self-certification that I think many of you are aware of, and so we've worked to counter those. For example, there's automation that goes out and looks at the project, and for example, if we can determine, well, you may say that this is true, but it's not. We don't care what the human says. You have to actually make that true. We also require public display of the answers. That enables criticism, whether or not those are actually true. Whenever you create some sort of criteria, you need to come up with some sort of grading criteria, some scoring system. Here's the scoring system that we use. We have 3 different kinds of criteria: must, should, and suggested. Most of them are must or must not criteria, and they must be met. Should criteria can be met or possibly unmet with justifications, and suggested they can be met or unmet. At that point, we are fundamentally depending on psychology, because most people don't like admitting when they don't do something that they admit they should be doing. I believe this is actually effective. In some cases, we do require UL in the justification to point to specific evidence. Currently, we only have 1 level. We do eventually hope to have multiple levels of badges, but right now we're working just on a basic level, what we're called passing level, that attempts to capture what well-run projects typically already do. And this is important to understand. The level that we're focusing on is what do most projects currently do for each of those criteria, not what should they do, but no one actually does that. We're not interested in those criteria, some sort of magical ideal. And we're interested in what projects actually demonstrate is a doable thing. And we intend to update these criteria annually. Whenever you talk about criteria, it's probably useful to show some examples. What do these criteria look like? Here's just a few. Hopefully we'll give you a flavor of what this looks like. Basics, for example, the software must be released as flawless. These are criteria for open source software. It makes no sense if it's not actually open source software. We suggest that it be licensed under the OSI. There are some reasons some projects simply cannot change their licenses or choose a very unusual license. However, we do suggest, we believe that there are advantages to using an OSI approved license. Change control. The project must have a version control source repository. If you don't use software to control your software, your versions, your project's in a lot of trouble, frankly. It's very difficult for people to track, to determine what's going on. And therefore, that isn't a must. Under reporting, one of the musts is you must tell people how to report vulnerabilities. This turns out to be a problem for a surprisingly large number of projects. Many projects have only public ways of reporting vulnerabilities. But when of reporting problems of any kind, if I find a vulnerability in your software, should I report it that way? It's okay if you do, but you need to make it clear. Most projects choose to have private reporting of vulnerabilities. I personally prefer that myself. But regardless of that, please make it clear what you want people to do. Otherwise, when a vulnerability is found, there needs to be first this discussion about how to report a vulnerability. That's the wrong time to have that discussion. The project needs to determine ahead of time how to handle vulnerability reports. Unsurprisingly, we wish to have projects with quality. Projects with poor quality are unlikely to have good security. So if the project requires building for use, there must be a working build system. You can't possibly test it or use it or make improvements to it easily without that. It must have at least one automated test suite. If you don't have an automated test suite, again, you are unlikely to produce quality product. You are unlikely to be able to make significant changes because you won't know if those changes broke your software. Must have a general policy that as you improve it, you'll add tests. We actually don't have a coverage requirement, how much testing is good enough. That turns out to be difficult to answer. We can talk later about, for example, the Linux kernel folks have difficulty because many people do not have the hardware needed to test the software. Okay, but you can certainly at least strive to do better. As you improve your software, make your test software better. There must be some warning flags to warn you of common problems. Since this badge criteria were originally